So hello everyone, I'm Marco. Can everyone hear me or should I use the mic? Can you hear me? No? Okay. So I'm an API developer at 7 Digital and I'm passionate, actually I love open source development where I learned a lot of the things I'm presenting tonight. So 7 Digital is a company that basically provides an API for dealing with music, so you can stream, you can build your new online radio like Pandora, or a small shop that allows you to download Christian music, everything. And yeah, we have quite a lot of topics tonight, so we'll see. I will try to go as fast as possible to cover them. And we'll start by looking at how we were coding JavaScript in the past. So we were having our nice like pint.js file, which was a simple JavaScript file with a bunch of functions, a bunch of variables, and everything was basically global. And when we started doing more complex JavaScript, problems would arise because obviously we would be conflicting between the various files. For example, we here created a new file called half-pint, which should show some more a different behavior. And actually, we would get many errors because everything would be ending up on the window global object, and because the variables defined in JavaScript live inside the function that are enclosing them, or if there is no function, they will end up on the global scope, which would be the window object in a browser. In JavaScript, code blocks doesn't scope variables, so you must be careful with that, otherwise you could be conflicting yourself in the same function. Another thing to be very careful when doing more complex JavaScript is hoisting. Basically, in this example, we can see that, as we said, no matter how you define a variable in the global scope, it will always end up in the window object, so the first three definitions are exactly the same. And then we have an inner function, which is defining a variable, and this variable is accessible inside the function. And then we can see here a console.log first outer is variable, and we would be expecting it to show 20, but actually it will show undefined because we have a variable of 30 defined inside a code block. This if true equals var variable equals 30. What actually happens in the background is the following code. So all the first three definitions are exactly the same, but the variable in the outer function has been hoisted at the top. So now it is very clear why we are getting an undefined. So basically, yes, all the variables are function scoped. They are hoisted at the top of the function, and redeclaration of the same variables is a non-operation. So you must be very careful about this. And to allow us to build more complex JavaScript code, so if you want to build a quite complex, for example, object domain, you need to consider all these things in your development practices. Otherwise, in the long term, especially if everyone is doing JavaScript in a different way, very easily you could get up in trouble. One thing that has been implemented in the recent browsers is the strict mode. For example, the strict mode makes JavaScript a little bit more sane. The simplest example is that if you are trying to access a global variable that has not been defined, it will throw you a reference error exception instead of just silently creating the variable on the global scope. And many other things has been implemented in the strict mode, so it is very useful, and all the examples will include the strict mode in the code. And another thing that has been proposed by the community, specifically by Douglas Crockford is the 1 var per function rule. This is highly debated and controversial practice, but what it means is that you are writing code in the same way as the JavaScript parser will then execute your code. So instead of spreading your variable definitions all around a function, you define them at the top as the first instruction. In this example, we can see that we have 1 var and a bunch of values defined. And this is exactly how the browser will behave. And as an added bonus, the single responsibility violation will be very clear, because you will end up having at the top of your function a big number of variables defined, and you will decide, perhaps I should split it into different methods. And another tool to keep things sane in JavaScript development is JSHint. JSHint is a community-driven best practice checker, and this is the one that you can see here is a configuration file. The example here is that undef equals true and unused equals true means that if you are trying to access an undefined variable, an error will be shown in the error log of the tool. And for example, the same thing for the unused equals true setting. It means that if you will be just defining variables and not using them, an error will be displayed. And there is a lot of other things that helps. JSHint is supported by many different JavaScript editors, and if you work in a team, it will be very good to have a JSHint configuration and share that around your team, so everyone will be writing code in the same way. This could be automated also using Grunt, so you could add a watcher. Basically, Grunt is an automation tool in JavaScript, and it runs tasks for you, and you can add a watcher that will run in the background and constantly check all your source code so that it matches all the rules that you are defining inside your JSHint configuration. And a nice thing that has been implemented in the recent JavaScript engines is the let keyword, which basically is the same as the var. The only difference is that you can define a variable scoped in a code block. So with the let, we can have a variable in a for loop, and in this case, the I variable will not leak in the outside function scope, but will stay defined only inside the for. This is very useful when you do complex object models. So, closure. Closures, it is a special kind of object that combines two things, a function and the environment in which the function was created. The environment consists of any local variables that were in scope at the time the closure was created. This means that each time we return from a closure, all the code that was available, all the variables that were available will be still available, also if they were outside the scope. And here we have an example of how this is useful. So we have this outer function, which will be basically our closure. And the outer function has an outer variable defined, and this outer variable will be available from the inner function. The inner function will just simply increment the outer variable when executed. There is nothing strange about it. The particularity is that the outer function, when executed, will return the inner function, and this will allow us to have a pointer to the inner function, so we could execute it whenever we like it. But because of how JavaScript is done, which is different to other languages, all the stack of the outer variables will be still accessible also when we have returned the inner function outside. So this simply means that outer variable will be always available, no matter that our execution context will not be anymore the outer function. So here we are just taking two pointers to the inner function. So one is inner copy 1 and inner copy 2, and we can later execute inner copy 2 multiple times inner copy 1, and they will be affecting the outer variable from the outer scope in later. So, oh sorry. And this is the output that we will get. So here you can see that the outer function can access the outer variable but cannot access the inner variable. And when we do multiple executions, the values of the outer scope are incremented in a separate way. This is because every time you return a closure, a copy of the whole stack will be kept together with the closure. So the two different closures, also if they came from the same context, will not be interacting with each other. And this is the basis for creating objects in JavaScript. Another specialization, another basic thing to take into consideration are functions that are ifs, which are immediately invoked function expressions. And this is, the example is very simple. Here we can see that when loading the script file, there will be a function that will be immediately executed because of the open and closed parents, and this will allow us to have a granularity to decide what will be available outside this IFI, because everything that is written inside IFI will be kept in the scope of the function. So we need to decide what to show to the external world. As a convention between JavaScript developers, when you write a immediately invoked function expression, you should wrap the function in parentheses. So if you can see, before the function keyword and after the curly brace, we have two parentheses, because if the method is very long, it could be very difficult to spot that will be self-executing. Okay. The first and most simple way of creating an object in JavaScript is called object literal. Object literal is simply a key value pair between a list of key value pairs, and it could be nested as in this example, or you can also use non-valid identifiers like a string or an exclamation mark or a number, just by wrapping the value inside single or double quotes. And here we have our first example that was written in a global fashion, enclosed inside an IFI. So we will be able to decide what we want to put in the global state, and we'll create a global object called Pint, which will be obviously assigned to the window global object, and we'll have the same properties and same methods as before, but defined with the object literal syntax. The interesting thing is that whenever we access the object literal, a context will be created, and the context will be accessible from the functions inside our object literal by using this keyword. This keyword will always refer to the object literal's context automatically. You see? And from the outside world, we can simply access our code by window.pint.drink or simply pint.drink. So it will be very simple, but we are actually here. In this example, we will not be polluting the global namespace, because the only thing that will end up on the global will be the pint object. Quantity, consume, drink, and the other functions will remain hidden inside the IFI. Okay, the next one, which gives more flexibility, is called the module pattern. And JavaScript doesn't have the concept of private variables or private functions or anything, but we can achieve this by simply not making them available to the outside code, but having them available in the closure as we showed before. So in this example, we also, so I will go to the namespace a little bit later. I will finish with this module pattern. So here we introduce this point variable inside our scope, which will be basically our public API. The point variable will be our object, so we are actually creating an empty object, and then we have this quantity, fill, consume, and the other properties, and we can decide what we want to have on our public API by decorating this point object with more functions, more behavior, and we'll be then returning the point object, and this will make it public. But as we are not returning in any way for example, the underscore quantity variable, it will not be possible for the outside code to change or interact with these private variables, except in the ways that we want because of our public API. And the next thing I would like to show here is how to create a namespace. So basically namespaces are just nested objects with properties, and so we create our pub namespace on the window object, and the pub namespace will be assigned the return value from the IFI, which is our self-executing function. And the syntax is a bit tricky here, so I will try to explain it. So instead of being an IFI without any parameters, we have here our namespace as a parameter. And if we look at the bottom, we see that the if, instead of being called without any parameters, we have this strange syntax, which basically means if you have already something on the window.pub object, you pass that one to the self-executing function. Otherwise, you create a new object. And then what we do is that we add whatever we like to our pub namespace, and then we return that namespace, which will be assigned to the global object called window.pub. Is it clear? I think so. Okay, and yeah, basically a little bit more polished version of the module pattern is called the Revealing module pattern, which was created because people were fed up with having to repeat many times the current object. So it is the same. The only thing is that we don't have to define a holding module. We just write as we would normally write all our functions, our variables, and whatever we like, and then we return object literal. Sorry, we set an object literal on our namespace, and we return the namespace. And this is quite nice because it is very concise and very understandable what will be the end API, public API of the object. To access this, to access the functions of these objects, it is just a matter of writing pub.pint.rings. So it's very simple. Okay, and now let's go on to the classic JavaScript object programming. So JavaScript's programming model is a classless, prototype-oriented or instance-based programming. What does it mean? Is that it has no class keyword, so you need to use a different way of creating your own objects and your own instances. So in JavaScript terms, to define a constructor, you just need to create a function as you normally would. And here we have our nice function called pint, which will just assign a default value to quantity. And we need to be careful here, because when pint will be called, it will be called as a constructor, so an context will be assigned to the function. So the function will automatically become an object. And this is why we need to access the instance of that function's context via this keyword. So we cannot so the best practice is to put the properties and just the values on this on the context, because the values will be different, and a copy of the values will be in memory for each instance of the object created from the constructor. It is a different story for the methods, because with the a nice thing about the classic JavaScript object with the prototype is that you can put all your methods on the prototype object, and the prototype object will be only one, no matter how many instances of the object you have. So the prototype will not be copied over and over every time you instantiate a new class, sorry, a new object. The prototype will be only once in memory, and this means that if you have a large running application, the memory impact of the methods on the prototype will be minimal. And again, to access the instance values, you need to use this keyword on the methods that lives in the prototype. And yeah, in JavaScript, by convention, if you have some variables or methods or anything that starts with underscore, are meant to be private. In this example, and in the usual way to do, in the usual way you do classical JavaScript object-oriented programming, you cannot create real private methods, because to be able to create real private methods, we need to do the closure scoping as we did before, and this means that every private method will be a new copy in each instance. So this will make your memory grow in a complex application. Okay, and to be able to create a new instance from our constructor, we need to use the new keyword. So in this example, to get the pint instance, we just need to do new pub.pint, which is our constructor, and then we have a reference to the instance, and we can access it like we did before, which is just pint.drink. Okay, so now let's go a little bit deeper in the prototype inheritance. And to do inheritance in JavaScript using the classical model, we need to create a chain of prototypes. So from the base class, we have its own prototype, and each specialized class we have a reference to the base prototype. In this way, we can layer our code and make at each step even more specialized classes. So let me go here. Is it big enough, or should I make it? So basically, this is the same example as we have seen before, but to be able to have multiple types of multiple inherited objects, we took the common logic that was present in the same object, and we have moved it back to the glass abstract class. So we have our class, which has basically most of the functionality, but has also a base constructor. And it is the same thing as the previous pint example. Simply, it doesn't know how much beer it could fit in the glass. So each class that is going to specialize this abstract class will specify this detail on the context of the object that is going to be created. So all the code that would be run in the base class constructor will not run in that object instance, but will run in the current instance that is going to be created. Is this clear? Yeah. So then to be able to inherit a base class prototype, we should use this syntax that is available in most of the recent browsers, which is, for example, pint.prototype equals object.create, and then we pass which prototype we want as a base class. In this case, we want the class prototype. So what will happen here is that our new object will start with a prototype, which will be a copy of the base class But we need to be careful because we need to change the constructor, otherwise the constructor will be pointing back to the class, back to the class and not to the current constructor. It is not very clear how this could affect running code, because usually the code doesn't seem to be affected by a wrong constructor, but it is a best practice to fix the pointer. Another thing to note is that the object.create syntax is available in Google Chrome 5, in Firefox 4, in IE9, Opera 11 and Safari 5. And so the AS5-shim project provides something that's called a sham, which is basically a backward compatible way of backward compatibility that you need to layer on top of older browsers. So if you want to call this in IE8, you need to have AS-shim loaded, and then you will be able to use the same syntax. And yeah, we can see that basically also half-pint is doing the same thing, and it is just calling the base class with a different value as the constructor's parameter. Okay, and the usage of the inheriting class is the same as before. We just do a new and pub.pint, and we get a reference to the instance, and then we can do pub.drink, pint.drink. The interesting thing here is that JavaScript will be going through all the prototype chain up to the object to find the method you're referring to. So it doesn't matter how many levels you can go. You can have a very complex inheritance tree, and JavaScript will go down all the levels up to the object to find your method. And the same thing happens with this instance of keyword. So if you want to know if your object is actually an instance of a certain type of class, you can use the instance of keyword. And in our example, the pint is actually an instance of pint, but is also an instance of the base class called glass, because it is. But it is not obviously an instance of the half-pint, because they are two different specialized classes. But all of them will always be an instance of object, because everything is inheriting from object. And the same thing happens here. The instance of keyword will be looking at the prototype of the class on the right-hand side. If that one is the match, it is true. Otherwise, it will go up in the prototype chain and look at the parent's prototype, if that matches the right-hand constructor or not, and so on and so on. Okay, and so obviously in JavaScript you don't have any type of way to specify some strongly typed variables, or have to say, okay, yeah, this is a constructor, this is abstract, or this is something else. And JSDoc helps with this. So it allows us to generate some JavaScript documentation, but it allows also us to enrich the intelligence of an editor. Here we can see how with this comment syntax we are telling JSDoc that class is really a constructor. It has a parameter which is called quantity, has a description, and quantity is a number, and it is abstract, so it shouldn't be initialized directly. And we have also a property which is called quantity and is private. And we can do many more other things. For example, yes, here we have other informations about the parameters. We can specify information about the return values. Here we can say that this getQuantity function is actually returning a number, which is the quantity in fluid ons. And another interesting thing is that you can actually say if a constructor will be extending another constructor, another class. And this is the extends syntax. And how is this used? So, for example, this is WebStorm's IntelliSense. Here you can see that I am in the half-pint constructor, where I do this as I'm using this keyword, and it is meaning I'm referring to the instance of the half-pint. And because of the JSDoc comments, the IntelliSense can tell me, oh, okay, yes, you have also the quof, string, getQuantity, which are available in your base class, because it knows about the extend keyword, so it can actually show you intelligent IntelliSense, which is not always so intelligent in JavaScript. And the getQuantity method, it is also telling me that it will be returning me a number, because it is getting it from the definition in the comment. And in the next example, we have this _consume, and it knows that I need to specify a number with a quantity. Otherwise, JavaScript will not be able to know this information. Especially, it will not know that it is a number, because there is no number type in JavaScript that you can define. And another thing is that it can show you the documentation for a method. For example, here it shows us that it will return a number, that it returns quantity in fluid ons, and so on. And it also does, for example, parameter checking. So the consume has a parameter which is a number, and it has not been specified. So my IDE can tell me, oh, look, you should be actually setting a value. And it also allows me to see my object graph in a structured way. So in this example, I commented out the extends comment for the half-pint, and I left it for the pint. So on the left, you can see that my editor knows that the pint is extending glass, and glass has a set of methods. But it doesn't know that half-pint is extending glass as well, because I commented out the information. And this is very useful, especially if you are building complex object domains, and if you are working with many people. This will allow you to actually share knowledge in a more semantic way. And the next thing that I would like to show you is CoffeeScript. CoffeeScript is basically very similar to JavaScript, but in a much more compact syntax. And the nice thing is that it has been designed to have the class keyword, the constructor keyword, and many other keywords that are very useful for doing object-oriented JavaScript. And as we can see here, instead of doing a function class, we actually telling that we want a class called glass. And this is a lot more readable. And the same thing for a constructor. We can actually define a constructor function which will be having the quantity parameter. And this will be very explicit, because it will be very difficult to misunderstand which one is the constructor and which is not. And to do inheritance with CoffeeScript, we are also get a very nice syntax, which is class paint extends glass. So it is very, very, very understandable. It is very simple. And then we have our constructor, which when it is executed, it will have access to the super, which is the parent's constructor, and we'll be passing down the value. And also this syntax for doing object-oriented JavaScript is way much simpler and way much more useful than the standard JavaScript way of doing it. And the next one, oh sorry, I need to again switch to the IDE because the highlight was just completely gone mad with TypeScript. I will make it a little bit bigger. So TypeScript is again a superset of JavaScript, and it has its own syntax for doing object-oriented JavaScript. I would say that the biggest difference between TypeScript and CoffeeScript is that TypeScript actually is typed, so you can define the types of the variables, what is being returned in a strongly typed way. And so instead of doing those ifs for creating our namespaces and for enclosing our code, we have the module keyword which does it for us. So we have our module pub, and then we can say I want a class called glass, and I need to say export because it must be available from outside because I'm actually using it from outside. And here we define the quantity as a private number variable, property, and it is very, very readable. And then we have our constructor, which is expecting a parameter called quantity that is a number, and the same thing goes on for the rest of the functionality. So very, very, very explicit. And for example, getQuantity is a public getQuantity that is returning a number. So again, it's very easy to follow and very easy to implement. And this is the syntax to do inheritance. So it is class paint extend glass, very, very similar to the CoffeeScript syntax. Basically because they both took an idea from the ECMAScript Harmony, which is the next JavaScript version that will come out eventually. So the other benefits of TypeScript are as follows. For example, if I had this method called this.consume1 as a number, and it was defined as a number, if I change it to this.consume, for example, with a string, the TypeScript transpiler will show me a very useful error message saying that I cannot put a string where I should be putting a number, which is very useful in JavaScript because you don't have these things. And another example is if I try to use this.consume1 from the inheriting class, and as this.consume was private in the abstract class, cannot be accessed, so I will get again a very, very useful error that will say that consume is inaccessible. And the future is called the ECMAScript Harmony. I think that the version will be like ECMAScript 6.1, which is basically JavaScript, but a version that will come out I don't know when. And this will be the syntax for doing object-oriented programming in JavaScript with a new language. As you can see, they introduced the class keyword, the constructor, and they introduced the extends as well, and the super. Here, and this is basically where CoffeeScript and TypeScript got their syntax. They simply looked at the future JavaScript syntax and they just replicated it. So actually there are no browsers that support this, so you cannot run this in a browser. But using the Google Traceur, I don't know the pronunciation, which is a transpiler, it will generate JavaScript that is compatible with the current browsers. So one day, I know in probably 5 years, when ECMAScript Harmony will be mainstream, you will be able to just drop the transpiler and just use it as plain JavaScript. And this is just a small subset of ways you can do objects in JavaScript. There are many, many more. So, for example, there is CommonJS, AMD with require.js, jQuery extend, which allows you to extend objects, and you have Dojo, which has functionality for doing objects and for extending and doing inheritance and everything. So there is really, I don't know, hundreds probably of different ways of doing objects with JavaScript. And that's it. Questions?
One question. So in the TypeScript version of your Pine class, you still were using the underscore while you have a private keyword, so I'm not sure.
Yes, so I use the underscore just to make explicit that that is a private variable, because if someone will be using my JavaScript generated from sorry, the question was why I'm using the underscore in the TypeScript where I have the private keyword, and the answer is that TypeScript will generate JavaScript. So if I'm distributing my object to other people looking at it from JavaScript, we have no way to understand that that is a private variable, and so by using the standard JavaScript convention, it will be explicit to everyone.
Any other question?
Any question?
Thank you.